So for the month of February, I've been working on a few things, while trying to work out the best way to approach the project. The stuff I'm going to show probably won't look like a lot. That's because half the month I spent researching art direction, drawing up some designs for a main character, which I won't be showing off yet. Originally I was planning to make some art for the game, to give the project kind of a bit of an identity for YouTube. Then I realised I'm putting YouTube before the project itself. So instead I spent a few days planning out a minimum viable product, and listed all the bare minimum elements required to make this game actually function. And then plan the project out into two phases. The first phase is to get the game fully functioning with placeholders, and then the second phase is to go through and replace all those placeholders while introducing a few more visual changes with regards to like player animation, aiming, IK and stuff like that. Each of these phases are then divided into a list of milestones. Once I did this, I actually wrote a script for a video and recorded the entire thing in terms of like audio, and then I realised I was putting YouTube first again. So then I trashed it before I started editing. That's because the first video on this channel actually took me about 2 weeks to make due to all the footage collection, planning and narration. This meant I couldn't actually work on the project for this period. This is fine for the odd video, but to do this for every video is just far too much. So this time I'm trying to do this live, so it's going to be a bit more casual. So I've actually been refactoring the power system entirely. So this might be why it doesn't look like a lot has been done, but behind the scenes there's been a lot of changes to try and make a bit more of a solid base and make all the code a bit more expandable. So this here is a power socket. As you can see, there's a power socket script on it. So when we get these plugs and we plug them in, obviously that's what it plugs into, and then that kind of gets the information from the generator to send then to whatever. This is another plug socket here. So before there used to be an enum here. So an enum you'd write out like enum, item type, and then you'd have like in here, we'd have a list of items. Power cable, power cell, gun, or whatever. The reason I did it like this originally is because it was just easier to do. So like each of the way this works is each of these will have a number assigned to them. You can actually assign the number yourself. So without going too technical, like you will have these in powers of whatever, they'll kind of go up. That's basically so they're bits. So the reason you'd do that is so you can create a thing called flags. I'll try and find footage of what it used to look like, because I think I did record some. But you'd open it up and a list would drop down, and then you can kind of choose what items would be associated. Basically that's a really bad system if in the future you want to expand it. So I've changed it to this. So this is basically a custom property drawer that I've created. This power socket, the only things that can be connected to it is a power/plug. And then say if we wanted to make it so you could have a power cell connect to it or a weapon connect to it. Every power socket is only going to have this one. That's just going to be the standard. But you'll see like with the key socket's got the same property drawer on it. So we can then add in a gun or whatever. So where's it getting this information is, so now we've got these scriptable objects. So this is now like an item, it holds all the item data. You have the item category, so like on this for example, and we've got like the category would be power or weapon, and then you've got whatever it's called. The category, so it's weapon, gun, and then the animation type, what animations it will trigger. So this is what the enums would be like before. And then you've got like holster type, a carry style. So carry style is how the character holds it. If they hold it in one hand, right hand, left hand, EVAT, or two-handed. Holster type, so if you can holster it, so if it will go on your back or it'll go in your pocket, like that kind of stuff. These things will be expanded, but they're fine as enums because they're not going to be expanded too much. The way I create these, I can just go here and I can go into data, item type, and create a new one. So now I can just expand these quite quickly. So we go onto the item itself and you can see here there's a type, and then we can choose from the list of types, or you can search if we want this one to be a power plug. There you go. When you're carrying this and you come to this socket here, it does a check and it goes, okay, you're holding that item, and then we can connect it. We can, any item in this list. On the weapon charger, for example, we've got a list of power cell, weapon handgun, and weapon rifle. So if I'm in game and I'm carrying power plugs in my hands, I can't place it on there. But if I've got the handgun, I can. And then it's the same with the power cell, we can put the power cell on. And it's the same thing with if we go up to this. This has only got power plug on it, so it won't accept power plug. But when we're holding power plugs here, power plug will connect. And the same with that. So the reason I've reworked that is so now it's more scalable. We can just add these new types in really easily. Basically making it a bit more future-proof. Once we put this system in, we then broke a lot of things. So we had to kind of rework a few of the power devices like the battery and that. But these I actually revamped entirely again. Originally they would use a thing called an interface, which you don't need to know too much about. You kind of put an interface and something and it goes, oh, okay, I know that every script of this type has these like elements within it. We changed that to something called inheritance. See, when we open a battery script, it says battery and it inherits from something called device. And then if you go into device, then device has got these. So every device has these functions within it, so they all share the same thing, and then you can then reference just any device. So on the power sockets, for example, the power sockets and the key sockets, it needs to have a reference to a device that it's connected to. It will only show everything in the scene that has these devices, that has this device script on it. And that means it could be, any of these could be a battery or a generator, or there's like a generator, battery, door interact, which I'll show what they are in a minute. The generator is a device, the battery is a device, the charger that I showed before is a device. The door itself isn't a device, it's something that we call a mechanism. The device part of it is actually, we've got this thing called a toggle trigger. This power socket then interfaces with toggle trigger, and then the toggle trigger then interfaces with the door. The reason I've set it all up like this is so now we can connect the plug socket to the device, and then the device then controls the mechanism. So then we can swap out the mechanism for anything, and this is like a standard thing. We've got two of these at the moment. We've got a toggle trigger, which is this one, and over here we've got an interactive device. Actually, I'm going to rename this one. Toggle device. There we go. So I've renamed this because it was toggle trigger, it was the old name. So it's a toggle device. I'll show you how that functions. We connect the generator to this here, to the power socket, and then it opens. So this one's basically when the energy amount is met, it just opens. It's just like toggles it on, toggles it off. It's the same with how the key sockets work. So this key socket, we drop it in, it doesn't work. So if we power this key up, give it a second. Right, so this is charged up now. So then if we connect this, it will toggle it. Before we used to put the settings on the key socket itself. So now I changed it so that you have to connect the key socket onto the device, and then you can kind of set if it drains the energy, if it just requires max energy, or if it's connected only. At the moment it's set to drain energy, so you can see like the energy's draining over time. And then when this number reaches 0, you'll see that the door's shut. There you go. So you can see like now there's not enough energy to keep the door open, it's closed. So the other one is the interactive device. I've connected these two batteries here. So now when I press the button, it will open. Now you'll see that the lights have gone red and we can't close it anymore. That's because the power that was in the battery has been drained. So the way this works is when you interact with it, it will pull whatever energy is around that it can to then open the door. I've set this up so you can't close it, but you'll see on the interactive device there is actors toggle and no off requirement. The actors toggle is just because of the mechanism itself. The way it works is you've got obviously an open and close, so it's like acts as a toggle. It's not just one single thing that is on. So this is just for depending on what device is connected to. So you'll see when the actors toggle is turned off, it doesn't show up. When you turn it on, then it says there's a no off requirement. So if you tick no off requirement, it means you can close the door with no power. So in this case, we can close the door, but we can't open it again. Even though there was no power, we could still close it. Now we've put some power into this battery that the cable's now gone this like bluey color. That means there's enough power coming from this cable alone. So we should be able to open it and then close it open, and then it'll go red because we can't open it anymore. But this is pulling from the generator at the moment. It'll just keep working as long as there's power in there. You'll see at the moment that we've got one cable that's red and one cable that's blue. So when I open this, you'll see that it's taking power only from that one. And now that it's gone green, that's because there's 25 energy in this battery here, and this requires 10 to open. So what's happening is it's taken 10 and then 10, and now it's only got 5 left. So it can only partially take 5 from this, and now it needs to take 5 from this one as well. So then when we open this one more time, you'll find that this one will go red and this one will go blue. So now all the energy is being pulled from this cable here, and then it goes red. So this is like kind of part of the cable rework. I've kind of reworked the cables to function completely different. Before there used to be a lot of events that kind of, from like a generator, it would send energy, but then a battery would not send energy but only wait for a draw from a device, and it was kind of convoluted and a bit complicated. So I've kind of simplified it a lot and then reworked how all these cables and everything work, so now you can actually see if there's enough power being sent. So this is kind of the same situation with chargeable items. So if I use this the energy up in this gun, so now the gun's empty. If we put the gun on here, you'll see that it's giving green for both batteries. I've set up like a rate system now, so the maximum draw this charger can get up to is 5. That's like the maximum speed at which it can generate the energy of whatever's connected to it. But batteries can only send 3 energy each. So it's taking 3 from one and 2 from the other. You'll see that this battery will run out before that one does over there. And then now it's gone to that. And that's still not drawing the full amount of energy, so it's only showing as green. So to show what's going on with the charger and the batteries and the transfer of power and everything, I've set up these little tester devices that show how much energy is being transferred per cable. So like there's 2 set up here, they've both got 2 sockets on them. And I've also added 3 sockets to this one battery, so you can kind of see how all of this is modular and how you can kind of expand upon it and little interesting quirks that can be achieved from it. So if you imagine this here is a charger, so if we connect this into it, you'll see that it goes up to 3. So now there is 3 energy being transferred from here into this. Then if we were to disconnect this from the battery and put it into the generator here, it goes up to 5. Now, these are set up so they have a cap on them, so the maximum energy they can receive is 5. So in the case where we connect a battery to this, and then we connect another battery, such as this battery down here, you'll see that now it's capped out at 5. So you'll see that this is green here. The reason it's green is to say that it's taking partially the amount from this one and partially the amount from this one. Whereas when you put it onto the generator, it tells you that it's transferring a full amount from the generator into this. And you'll also find that this one over here, this battery, is now the cable's red to say there's nothing being taken from this. So if I plug it into this one, it'll be the same. So no energy's been taken from this. Some interesting perks that come with this that I kind of was not intended, but I might keep them as this way because it creates some kind of interesting stuff. So from this battery we can connect this into here so it goes up to 3, and then we can also connect this one so it goes up to 5. From the same battery we're now drawing 3 from this one and 2 from this one. So potentially we could use a battery as some kind of way to relay power. So the amount that's going in and the amount that's coming out is equal. So we get 5 from this generator into the battery, and then from here we've got 3 going into here and 2 going into here, because this has a limit of 5. In a way, this cable's kind of being wasted. Say in the case we've only got 3 cables that we can use, this cable is actually losing some of its potential. So if we were to take this out and put this into this one, we've now got 3 on this one and 3 on this one, so a total of 6. But then obviously the power going in and the power coming out is not equal. So now you can see that there's a bit of a crazy glitch going on here with the with this constantly turning on and off, and that's because it's actually reached the point where there's no energy. So you can see the average on this one's gone to 2.4. So the transfer obviously is now, there's not enough, it's not drawing enough. So this obviously could work two ways. We could have 3 generators connected to this battery and make it charge quicker. Say you've got a battery in a room and you want to, say you've got this cable here and you trail it all the way through multiple corridors or whatever, all the way over here, and then we go all the way into the room where there's a generator and connect this battery into it. We can then have like the battery in a room where there's like multiple devices like for charging weapons or whatever. So that's kind of all the refactoring of the power system. It kind of functions the same way, but it's just a lot more scalable now. Should be able to introduce new devices a lot easier and slowly refine some of the other aspects of the cable system and that. So let's move on to the more exciting thing. I don't know if you've noticed, but there's this little red person over here. Just turning around and kind of running around, running to this spot, running over there, stopping, running over here. So this is the early stages of introducing the AI into the game. So here we've got an enemy character, which basically uses the same model as the main character. I've refactored this actor system, so we've got actor, which is a script that all actors will have. The player also has one of these. So you see the player, this is the player at the moment, it's got one of these actor, and it has like, it's kind of like a central hub for all the other components that are connected. So with like the player, we've got like an actor movement script here, got movement input, and then we've got carry control as well. And then inside of this we've got animation control, actor turn, and then actor interaction script. So all that kind of stuff is connected to this actor script here. So this kind of in a way acts as like a central hub that everything speaks to, and then that kind of speaks to everything using an event system. So the actor system is modular, so on the player we've got like move control and all this kind of stuff, but on the AI we've got something called an AI mover and AI move logic. This is using Unity's inbuilt nav mesh system. So the AI mover, basically it sends information into the actor such as how fast the character's moving and all that kind of stuff, and then that sends information to the actor's animation control. So this is the same script as it would be on the player. So they both, basically all I had to do is drag and drop this on here, and then it would start animating with the AI movement. So this move logic here, this is what controls the movement of the AI. So we've got a state, which is, does it patrol or does it pursue or does it do nothing? And then we've got a target. This is used for the pursuit. So when it's pursuing whatever, it will go to this target location. And then we've got our stopping distance, how far it's going to stop from when it arrives at that target. So if we set it to pursue, and we've got a target location, we set this to 1. So the target location, if you double click that, is this orange ball here. So we could put the orange ball over here. So if I move this around, you'll see that it'll just follow it, because it's set to pursue at the moment. So it will pursue this orange orb no matter what. So if we press on the target location, this is also doubles up as an AI patrol. So you'll see that there's this like purple line thing. Again, this is still work in progress, so in future you'll be able to click on these. See, it just clicks off it. But in future you'll be able to click on them and we'll be able to move them around and stuff. But at the moment, you have to set them manually here until I change it in the future. But this basically is move to this position, then move to this position, then move to this position, blah, 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 blah. Set the enemy now to patrol. So now we've got it set to patrol. We'll follow this line, run to these points, and then stop for a second, and then run to this point. So at the moment, so you'll see that it will eventually reach to this first point here, and then do like a little sequence. That's because on the target location we've got these commands. So turn to this direction, wait, turn to this direction, then wait, turn to this direction, wait, turn to this direction, then wait. So the idea of this eventually will have play animation or all these kind of different things in this. In these, there's only wait and turn at the moment, but we'll have play animation and whatever added to this. So we can kind of have an enemy move somewhere and then play an animation in like a sequence. So the other aspect to this is we've got a patrol type. As of right now, we've got it moving forward. So if we label these 1, 2, 3, 4, 5, 6, that is like the forward. So it will go from 1 to 2 to 3 to 4 to 5 to 6. But then if we were to set this to backwards, it'll go to this one, perform the action, and then next it will go to 6. So next go into 6. And then to 5, and then to 4, and then to 3. So you can see that by setting the patrol type to backwards, it will go through the sequence but backwards. And then we've also got palindrome. So palindrome would go from 1, 2, 3, 4, 5, 6, and then 5, 4, 3, 2, 1. So you'll see. And then the final one is random. So the way random works is it creates a list of all the points and then jumbles them up and it'll go to random 1. So this one's already done 3, now it's going to 5. But as you can see, it's just going to random 1s, but it will do every single one before it restarts again. So the idea is you'll have like an enemy that follows along a patrol line or whatever, and then when it enters like a pursue state, for whatever reason, it will then chase whatever it's chasing. So in this case it's the orange ball again, it's chasing the orange ball, and then it's going to go back to a patrol state and it will resume where it last was. Obviously there'll be like a lot more logic that will go into this, but this is just like the basic setup, so we can easily now switch between a pursuit and a patrol. So that's my progress for February. Next I'm going to be working more on the AI and improving that. I'm going to introduce like the detection, so detecting the player and then attacking the player and all that kind of stuff. That's going to be quite complicated, but I've made systems like that in the past, so it shouldn't be too difficult. Then from there I'll introduce like the interactions between the player. So for example, if we aim at the enemy, there's kind of no interaction at the moment, we just shoot right through them. But we'll start introducing all that kind of stuff, so we have hitboxes for the enemies and everything, so you can kind of shoot them, damage them, and then kill them. And then that will be like the next phase. So then we're starting to get a bit of a game together then. We've got our enemies moving and attacking us, and then we can shoot them and kill them. They can attack us and kill us. And then we can kind of, we've got like the energy system kind of set up. I'm not going to be really adding any more features than what's here at the moment. There's only going to be one enemy type, there's only going to be the power cables, 2 weapons, the power cell, wherever that is, the power cell, and like the generators, the charger, doors. There's going to be a few different doors that I haven't introduced yet. I'm going to have some doors that are like more manual use, that are just like normal doors, and then you've got like these kind of powered doors and everything. And then there's one more device that I'm going to add, which is like a constructor. So the idea would be you kind of connect it to the power. It'll be the first device with like an actual menu where you go, okay, I want it to construct this item. When all that stuff's in place, we can then start building a level. So all of this is what the game's going to end up looking like for the time being, but we'll start building a level so we can actually test all these systems out together and have like actual enemy patrolling in the area, and then it chasing the player and us having to have an actual goal in mind to like try and escape the place or whatever. And then when that's done and it looks great and it works great and I've got a few people testing it and we were all happy with it actually functioning as a game, then I'll start filling out the art and making it look pretty. But yeah, that's it for now. I kind of got things to do, so would you kindly bugger off?